Hey everyone, welcome to AP Chemistry Study Group. This is a safe and friendly environment where our goal is to be as prepared for the AP exam as possible. If you have questions, you can either put it into the chat or just ask it out loud. Usually with bigger groups, we'll have breakout rooms to promote more discussion. But since we only have 7 today, we'll just all stay in the main room. So if everyone's ready, let's begin. Does anyone have any prepared questions to start?
Yeah, I had a question about unit 2 bond order. I'm a little confused on how to calculate it and what's the significance of it between like atoms and molecules.
Yeah, so for this question, we'll probably need to talk about resonance structures first. Resonance is basically a way of describing bonding in certain molecules when there are several contributing structures. For example, O3 has 2 resonance structures because there are 2 potentially equal dot structures that could be drawn. And we need this because it's part of the bond order equation, which is basically number of bonds over number of resonance structures. For example, O3 has 3 bonds and 2 resonance structures, making the bond order 3/2.
Also, bond order can help determine the length of the bond. So the higher the bond order, the stronger the pull between 2 atoms or molecules, which means shorter bond length. According to Coulomb's law, the shorter the bond is, the more stable the molecule because there's more attraction between the nuclei. And the lower bond order means a longer bond length, which means a less stable molecule with lower attraction between the nuclei.
Thank you.
I have a question on Unit 5, mphoteric acids. How do we determine whether to use a Ka or Kb value when you set up an equilibrium?
Okay, so I can take this question. Basically, we have to go through like the definition of amphoteric first. So basically, an amphoteric acid is like a molecule which can act both as an acid and as a base. So for example, we can take HSO4, right? So so let me just share my screen first. So HSO4 can act as an acid, which is a proton donor, or a base, which is a proton receiver, right? So for example, if it's a proton donor, we can write the equation HSO4 minus, can't forget the charge, can we, right? Or minus, and then we can set up an equilibrium reaction to H plus and SO4 2 minus, right? So this is HSO4 acting as an acid, right? And then we also have a Ka value for this one, which can be obtained from a Ka chart. So the Ka value of this reaction is 1.2 times 10 to the negative 2, which again can be obtained from a chart that will be provided on the AP exam, right? So 1.2 times 10 to the negative 2. But at the same time, right, because HSO4 minus is an amphoteric acid, it can also act as a base, right? So if we do HSO4 and then we let it react with water, HSO4 minus, and we let it react with water, then it can create a hydroxide ion as well as the conjugate acid, which is H2SO4. So it will create a hydroxide ion. So HSO4 minus will be the proton receiver, and then making the hydroxide ion and an H2SO4. So because this is a base reaction, I'm pretty sure there is a Kb value. So you can't necessarily find this Kb value on a chart, but I'm sure there's like a way to calculate it. But I think like I forgot how to do it. So can anyone help me here?
So okay, that. So basically to calculate the kV value, you need to use the equation Kw equals Ka times Kb. Okay, so we know that Kw is 1 times 10 to the negative 14th, right? And we have the Ka value from the chart. So we also know that Kb would basically equal Kw over Ka. So that being said, what does Kb equal?
Okay, yeah. So basically we can calculate the Kb. So as Brandon said, Kw is 1 times 10 to the negative 14. And then we have our Ka from the chart, right? So we can set this equation up, and then we have this value from like the chart here, right? And then we can calculate Kb by doing Kw over Ka, right? So after we have both the Ka and Kb values, we need to compare like which one's bigger to like determine whether we use the base version of the reaction or the acid version of the reaction. So does that make sense, Alex?
Yeah, that makes a lot more sense. Thank you.
Cool.
Hey, so I'm working on the 2014 AP Chem free response questions right now. Um, can someone help me with question 2A and 2B?
Yeah, I think I did this one before. Hold on, let me find it. It's the one with propanoic acid, right?
Yeah.
Okay. 2A. So to find the bronzoluric acid, it's going to be propanoic acid because it's the proton donor. Because if you look, when it goes to the right side, it loses that H plus that it had on the left side. So that was going to be your bronzoluric acid, which makes H2O your bronzoluric base because it's the one that gains that H2O when it goes to the right side. And then that makes CH3, CH2, COO minus your conjugate base because that's what happened to propanoic acid after it lost its proton. And then the conjugate acid is going to be hydronium, which is H3O plus because it gained that lost proton. Does that make sense?
Yeah.
Okay. And then for 2B, you just want to use the pH that they give you, which is 2.79, and then find the concentration of H plus from that, and then you'll be able to get the Ka value.
Okay, that makes sense. Thank you.
Welcome.
Okay, everyone. So our session is over for today. So our next session will be next week at the same time. I hope everyone has a good week. And I'll see you guys next week. Bye.